Well, when someone finds out that you are in kinesiology and you're taking a course on physiology of endurance performance, they may ask you questions like these. Can I qualify for the Boston Marathon? To qualify for Boston Marathon, you actually have to run another marathon. And in that marathon, you need to get your marathon time under a qualifying standard. The standards are always changing, so these may not be accurate right now. But for example, if you're a female in the 50 to 54 age group, you would need to run a marathon under 4 hours to even be considered for qualifying for Boston. Then there's still a process involved, but ultimately you need to be under that 4 hour mark to even be to have a chance to get into Boston. So a lot of people want to know whether or not they can do that. And they're asked people like you who understand physiology of endurance performance whether or not they may be able to. People may also ask, what should my training program look like if I want to do under 10 hours in an Ironman race, or under 12 hours, or finish an Ironman? Or should I shorten my stride length when running? Or what shoes should I run in? Or what intensity should I train at? These are all real common questions for us to get out in the field when talking with the endurance community. So Tim Noakes's chapter 2 in the Lore of Running deals with answering questions like these, or at least giving us the foundation of information to be able to answer questions like these. The chapter is focused on oxygen transport and running economy. And it's a big chapter, and it's really packed with lots of information. I've divided the chapter into 4 parts. Really, really 5 parts, but really the first part, Noakes talks about VO2 max. What does VO2 max mean? What do we know? Why is this an important parameter to know? It's an important parameter that a lot of runners like to brag about, sort of a badge of honor in terms of saying what their VO2 max is. What's that all about? The second part is running economy. This is a really important part. And running economy is, in essence, submaximal VO2. It's the amount of oxygen used to run a particular speed. And we're going to talk about running economy as well as energetic cost of locomotion. Two very similar, but yet two very unique parameters. And they each tell us something about running endurance or events. The third part is predicting performance. I'll go through what's in Noakes's chapter, but there's actually a lot of new, neat technology that can be used to predict endurance performance. And then the last part of this chapter is physiological changes with aging. And we'll go through that as well. Now, just to set the stage a little bit more for the content of this material in this chapter, remember the book is called The Lore of Running. So what's lore? It's something that is taught, learned, knowledge gained through the study or experience, traditional knowledge or belief of a particular body of knowledge. Okay, that's what lore means. Running, the lore of running, running is a form of locomotion, jogging, sprinting, those are forms as well that are related to running. Walking obviously is another form of locomotion, skipping, hopping even. But we're going to be focused on running. Now running is a gait pattern in which there's a point where both feet are off the ground. Whereas in walking, there is a period where both feet are in contact with the ground, so a period of double support. Now, we'll actually refine this definition at times because sometimes you can look at someone who's running, but yet they may also have a period of double support. And so we'll distinguish often running from walking, not only by double support, by whether or not the center of mass is at the lowest point in mid stance, or the point where the time where the foot's in contact with the ground. This is covered a little bit more in biomechanics of endurance performance in terms of the distinguishing features between walking and running. Now, what's important also is to define a stride and a step. And unfortunately, the literature is filled with confusing these terms or using one to represent the other. So you have to be really careful when you're reading literature to understand how the authors of the particular paper are defining a stride or a step. So a stride will use a complete gait cycle. So this is consecutive discrete events. A discrete event is anything that happens in a short period of time. For example, striking the ground. If you think about it in terms of going frame by frame in a video, your foot would not be in contact with the ground up until the very frame that it is in contact with the ground. That, in essence, is what a discrete event is. You can also define a discrete event like toe off, but most times we use ground contact as a discrete event to define the beginning of a stride. And then you would look at all the movements and time between two consecutive discrete events. So for example, two consecutive right heel contacts. So right heel to right heel. That all the movements and all the time between those two contacts would be considered a stride. A step would be right to left or left to right, either way. So the moment the foot strikes the right foot strikes the ground to the moment the left foot strikes the ground, all the movements and time between those two discrete events would define a step. Again, lots of different pieces of literature switch these, but this is how we refer to them in our lab here at UNLV, and it's commonplace amongst the literature. But I do encourage you to make sure when you read a paper to look at how the authors are defining a stride or a step, and that way you can be on the same page with them. The other thing important with this book is to know that Dr. Noakes is from South Africa, and he uses the SI system. So we really need to sometimes work a little harder to convert the units that are used in the textbook with what we typically use here in the US. Right or wrong, it's just we need to adjust our thinking. So for example, Noakes will use kilograms to represent the units of weight, even though really kilograms is units of mass. This is even another contentious point in the physics world. Nevertheless, if we have a 70 kilogram person, that means that person also weighs 154 pounds, or vice versa. 154 pounds means 70 kilograms. So you can see the conversion factor there of 2.2. I encourage you to take your weight in pounds and convert it to kilograms. So then when you're doing the reading, you'll have a context of whether or not 70 kilograms is a lot, 80 kilograms, is that a heavy runner, 90 kilograms, and so forth. That way you'll have a little better understanding of the material as you go through. We also need to convert kilometers per hour to miles per hour because the Noakes mostly uses kilometers per hour to represent speed. And you see the conversion factor there. So 10 kilometers per hour is the same as saying 6.2 miles per hour. So just be able to convert between those sets of units. Noakes also will use, and will also use, meters per second often to represent velocity. So the quick conversion is 2.2 miles per hour per meters per second. So roughly, if I'm talking with someone, I'll convert between meters per second and miles per hour by doubling the meters per second. And that gets me at least close to the number. Race pace, you'll see reference to this. It's just kilometers per hour, or sorry, the race pace would be time per distance. So minutes per kilometer, or here in the States, we'll typically say minutes per mile. And so again, we just need to be able to go back and forth between these sets of units. Noakes will also use Celsius to represent temperature versus Fahrenheit. And there's the formula for converting Celsius over to Fahrenheit. As my mother-in-law will say, who's from Calgary, Alberta, Canada, she'll say the quick way to do this is to double your Celsius and add 30. That gets you close enough for a conversation. The specific formula is to multiply by 9, multiply your temperature in Celsius by 9, divide by 5, and then add 32. All right, now I want to get into part 1A. I'm going to do a separate video for that. So that information that I just covered is sort of to set the stage for how to use this book, and I really encourage you to convert these units for yourself over to SI units, so you have so the reading is a little bit easier. Okay, thanks.